Now we will see the we will see the one example for a priori algorithm for this table. That means consider one another example for sales transaction containing containing the 5 transaction IDs and their item set. Then the item set will be first transaction ID will contain 1, 2, 3 and 5 item set. Then another second transaction ID will be 2, 3 and 5. Then another third transaction ID will contain 6 and 7. Then fourth transaction ID will contain 1, 3, 4 item set. And then fifth transaction ID will contain 2 and 5. Then a priori algorithm for frequent item set. Then we have to given about minimum support. We have to given about minimum support is equal to 20% and minimum confidence will be given that the 50%. Then calculating the C1 and L1. Then C1 will be a candidate generation and L1 will be a list of their item set. Then we have to find the C1. Then that means item set for particular transaction. Then we have to generate 1, 2, 3, 4, 5, 6 and 7. There are 7 items will be given in this example. Then support count will be frequency of each item set. Then we have to count the frequency for each item set. Then one, how many in this database can one, how many number of times will be occur in for particular transaction ID. Then we have to calculate 1 in how many transaction ID. Then 1, 2, transaction ID 1, transaction ID 4. When 1 will be occurred, then the support count will be a 2. Then second item will be 2. Then how many number of times will be occurred for to scan the database, and we have to count the support count. Then we have to calculate the support count. Then first transaction ID, second number will be occurred. Then second transaction ID, second number will be occurred. Then fifth transaction ID, second number will be occurred. Then the support count will be a 3. Then third number 3. Then 3, how many number of times will be occurred? Then we have to calculate and scan this database and to find out the support count. Then first transaction ID 3 is occurred. Then second transaction ID also 3 is occurred. Then fourth transaction ID also 3 is occurred. Then the support count of 3 will be 3. Then 4. Then 4, how many transaction ID, how many items set will occur in 4. Then frequency will be calculated for 4. Then fourth transaction ID 4 will be occurred. Then the support count of 4 will be 1. Then 5. Then 5, how many number of times will be occurred? Then 3 number of times will be occurred for transaction ID 1, transaction ID 2 and transaction ID 5. Then 3 number of times 5 will be occurred. Then 6, how many number of times will be occurred? Then 6, only 1 number of times will be occurred for transaction transaction ID 3. Then the support count of 6 will be 1. Then 7. Then 7 to scan the database, how many number of times 7 will be occur for each transaction ID. Then third transaction ID, only one value 7 will be occurred. Then the support count of 7 will be 1. Then we have to calculate L1 for each item set. That means then item and support count. In this specific condition we can apply in this C1. Then support is greater than equal to means then another transaction ID will be removed. The second step we have to learn about this a priori algorithm prune. That means removing the item set for this transaction ID, the value will be minimum. Then 1 will be removed, 6 will be removed, and 7 will be removed. Then we have to support is greater than equal to means for this item set 1, 2, 3 and 5. Then we have to place in this L1 table. Then 1, 2, 3, 5 numbers are occur. Support count are occurred in support is greater than equal to means we have given that support count will be 2. Then support is greater than equal to means that means 1, 2 and 3 and 5. Then next step. When calculating, in step 2, calculating C2 and LH. In this L1 table, we can create the pair of each item set. Then we have to generate this pair 1, 2. Then 1, 3, another pair will be occurred. Then 1, 5. Then next 2, 3, 2, 5. Two pair will be occurred. Then 2, 3, 5. Then 6 pair will be generated for L1 table, and then we have to calculate the support count. Then 1 and 2, they scan this database, and how many number of times 1 and 2 will be occurred in one transaction ID. Then 1 and 2 will be occurred in first transaction ID. The support count will be 1. Then 1 and 3, how many number of times 1 and 3 will be occurred to scan the database? 1 and 3 and 1 and 3 first transaction ID, and fourth transaction ID will be occurred. Then the support count will be 2. Then 1 and 5. Then 1 and 5, how many number of times will be occur for a particular transaction ID? 1 and 5. First transaction ID will be occur, then another transaction ID will not occur. Then we have support count 1 of 5 will be 1. Then 2 and 3. How many number of times 2 and 3 will be occurred in one transaction ID? Then we have to calculate support count 1 and 5. 1 and 5, only one transaction ID will be occurred. 1 and 5, only one transaction ID will be occurred. Then 2 and 3. 2 and 3. First transaction ID will be occurred. Then 2 and 3 second transaction ID will occur. Then support count will be 2. Then 2 and 5. 2 and 5. How many number of times will be occurred? 2 and 5. Then 2 and 5. First transaction ID and fifth transaction ID will be occurred. Then support count will be 2. Then 3 and 5. Sorry, 2 and 5 will be occurred in 3 number of times in transaction ID. 2 and 3 first transaction ID, 2 and 3 second transaction ID, and 2 and 5 first transaction ID, 2 and 5 second transaction ID, and 2 and 5 fifth transaction ID. Then support count will be 3. Then 3 and 5, how many number of times will be occurred? Then 2 number of times will be occurred in a 2 and 5, 3 and 5. Then transaction ID 1 and transaction ID 2. Then the support count will be 2. Then we have to calculate L2 for C1. Then we have to apply the condition support is greater than equal to mean sub. Then the value 1 will be minimum. Support count 1 will be minimum. Then we can remove it. And other pairs will be take on L2. 1 3, 2 3, 2 5, and 3 5. 1 3, 2 3, 2 5, and 3 5. When support is greater than equal to mean sub, then the value will be calculated. 1 2, then 2 3 support count will be 2, and then 2 5 support count will be 3, and 3 5 support count will be 2. Then step 3. Step 3 we can generate the candidate generation for C3 and L3. For creating the pair, we will first step we can find out the each item set frequency. Then another step 2 we'll have to calculate pairing of this item set, and then another third step we have to also calculate the pair of in second step we have to calculate 2 pair, and third step we have to calculate the 3 pair for to scan in this L2. In step 3 calculating C3 and L3, for we have to C3 for the subset of item set, and the item set will be together for subset in 3. That means EL2 one numbers will be occurred 1, 2, 3 and 5. Then we have to generate the 3 subsets of items. occurred. Then 1 to 5, 2, 3, 5. And then another 1, 3, 5. Another pair will be occurred for this each item set. 1, 3, 5 will be occurred, and then we have to calculate the support count for this given a priori algorithm table. A priori algorithm item set. Then we have to generate 1, 3, 1 to 5 in these three subset will be occurred in one transaction ID. Then 1, 3, 5. One number of times will be occurred. Then the support count will be 1. Then 1 to 5. 1 to 5, how many number of times will be occurred? 1 to 5. Then only one number of time will be occurred. Then the support count will be 1. Then 2, 3, 5. How many number of times will be occurred? 2, 3, 5. Then next transaction ID 2, 3, 5. Then support count will be 2. Then fourth item set 1, 3, 5. 1, 3, 5. How many number of times will be occurred? Only one number of times will be occurred. Then L1 value. Then L3. Then we have to apply the specific condition. Support is greater than equal to mean sum. Then we have this item set will be removed. The three item set will be removed and only one item will be